Okay, good afternoon, everyone. Let's start the event in this afternoon. Today we still have about 30 students need to read the slide. And before we start the event, I still need to explain why we need to hold this event. Because the key performance index of the Ministry of the Education, they require us to improve some interactive between the student and the teacher. So we use this event to verify. Do you know how to read our lecture slide? And do you know how to pronounce Asian the professional vocabulary we use in the lecture slide? Before we start, we introduce two websites. First one is the Unix, and this website can help you to find how to read some word. So we can find the YouTube and to see this following how to say this word. For example, the energy line we use in our lecture 5 for the inductor, and we can see
it is seen as a positive experience, and it makes you approach. It makes you is exhilarating. It's energizing.
So we can see energizing, and then we can.
He finds extroverts energizing, but a bit intimidating.
So we can listen to
something that's a little bit more energizing. And the great thing about both anxiety.
So we can see different one. They have a different answer. So we can listen many of them and then find how to correct pronounce this word. So I think this website is very good. Sometimes you didn't know how to read a word, then you just paste this word, and then can find the video that contain this word. And another website is the Microsoft text-to-speech website. You can use this, and you can just paste a sentence from our lecture slide and just use this AI generated voice to read out this sentence. Then you can learn how to read this word.
The susceptance BC is the reciprocal of reactance and is expressed as BC equals 1/XC. The admittance Y is the reciprocal of impedance and is expressed as Y equals 1/C.
So we can use this website, and you can change the speaking speed, and also you can use a different one.
The susceptance BC is the reciprocal of reactance and is expressed as BC equals 1/XC. The admittance Y is the reciprocal of impedance and is expressed as Y equals 1/Z.
So this word susceptance, sometimes you may not know how to pronounce this word correctly. Then you can use the Unix, or you just paste this sentence in this website, and they can help us to understand how to read this word. So for the EMI course, of course, our course is majorly focused on how to solve the problems for the circuits. But since it's a EMI course, so you need to know this professional vocabulary, and also you need to know how to read this word. And then you can use this in conversation, and then you can improve your talking ability. So it's some introduction why we need to make this event and how to improve your English reading ability. So if you have any problem, you can raise your hand and open your microphone, and we can make some discussion. And we list the page list of each lectures in this slide. So before we start, we will use the random number generator to generate a random number. So for example, if we generate a random number and the random number is 4 into from the 139 to the 235, if the random number is 4 within its range, then we will ask the student to start reading from the page 1 of this lecture. And every student need to read the lecture style for 3 minutes. And I will ask you to stop, and then the next student, they will continue to read the following page. So我想对我们前面讲述的这些，还有等一下要进行的方式，不知道有没有同学还有问题的？好，那如果没有疑问的话，我们等一下就要开始进行了。好，有问题吗？好，那我想那个刚刚介绍那2个网站哈，就是建议大家可以去用一下看看，这样子好不好？So we now start. So firstly, we need to generate a random number from the 1 to 364. So we get our random number as 30. So of course we will start from the lecture 1. And today we will start from the Mr. 苏静渊，在吗？在线上吗？请问一下，苏静渊同学在线上吗？好，不在。好，那么就换下一位同学哈。曾静瑶同学在吗？
喂，有听得到吗？
有，好，那就准备开始哈。
好。
Okay, start.
Scientific notation provides a convenient method for expressing large and small numbers. A quantity is expressed as a product of a number between 1 and 10 and a power of 10. Example 200. The advantages of scientific notation is in addition, subtraction, multiplication, and the division of very small or large number. Engineering notation is similar to scientific notation. However, in engineering notation, a number can have from 1 to 3 digits to the left of the decimal point, and the power of 10 must be a multiple of 3. The engineering notation is useful in electrical and electronic calculation that use metric prefix. Letter symbols are used in electronics to represent both quantities and their units. The following table lists the most important electrical quantities along with their SI units and symbols. The term SI is the French abbreviation for Système International. In engineering notation, metric prefix represent each of the most commonly used powers of 10. These metric prefixes are listed in the following table. Metric prefixes are used only with numbers that have a unit of measure, such as watts, amperes, and ohms, and precede the unit symbol. The Bohr model of an atom showing electrons in circular orbits around the nucleus. If an electron absorbs sufficient energy, it escapes from the atoms becomes a free electron. Copper is the most commonly used metal in electrical applications. In a piece of copper at room temperature, a sea of free electrons is present. These electrons are not bound to a given atom, but are free to move in the copper material. Free electrons make copper an excellent conductor and make electrical current possible. Conductors are materials that really low current. Semiconductors have fewer free electrons than conductors. Therefore, they are classes below the conductors in their ability to carry current. Insulators are poor conductor of electric current.
Okay, you can start now. I think your readings no problem. So we move to the next one. 甘义恒同学在吗？
有听到吗？
有，好，那准备好。Okay, start.
When an excess of electrons exceed in a material, there is a net negative electrical charge. Oppositely, when a deficiency of electrons exists, there is a net positive electrical charge. Electrical charge is measured in coulombs, symbolized by C. One coulomb is the total charge possessed by 6.25 multiplied
10 to the power of 18.
10 power of 18 electrons. Therefore, a single electron has a charge of 1.6 multiplied 10 power of negative 19 C. The total charge Q expressed in coulombs for a given number of electrons is followed by the following formula. A force exists between 2 point source charges that is directly proportional to the product of the two charges and inversely proportional to the square of the distance between the charges, which can be expressed in the following formula. This force, called an electric field, consists of invisible lines of force as represented in the following figure. Force is required to move a charge against the electric field. When force is applied over a distance, work done in moving a charge against the electric field leads to the definition of voltage. Voltage is the work per charge done against the electric field. 1 volt is the potential difference between 2 points when 1 joule of energy is used to move 1 coulomb of charge from one point to the other. Voltage is the driving force in electric circuits and is what establishes current. A voltage source provides electrical energy of electromotive force. Voltage is produced by means of chemical energy, light energy, and magnetic energy combined with mechanical motion. An ideal voltage source can provide a constant voltage for any current required by a circuit.
Okay, you can stop. Good. And I think no problem. And we move to the next one. 照这个字里面的引弦吗？还是这个照这个字怎么念？有同学在吗？这个赵同学在吗？好，确定不在啊。和言应该是这是什么号吗？
号，对。
号的 ，OK， 好，那准备好。OK， start.
A battery is a type of voltage source that's composed of one or more cells that convert chemical energy directly into electrical energy. In a battery, the terminal that supplies electrons is a negative electrode or anode. The electrode acquires electrons as a positive potential and is the cathode. The power supply converts the AC voltage on the wall outlet to a constant voltage that is available across two terminals. A basic numerical power supply is shown in
commercial power supply。
可它这里是拼错吗？
我有拼错吗？要帮我等一下回查一下好了，应该是没有拼错吧 ？Commercial power supply， 商业的那个 power， 就是一般的市面上商业的那个 power supply。
它这边拼错吗？
拼错是的，好吧，那我记一下。我是指那个 commercial 那个字哈。
好 ，A basic commercial power supply is shown in the following figures。
等一下，我记录一下啊。
Voltage provides energy to electrons that allows them to move through a circuit. This movement of electrons is the current, which results in work being done in an electric circuit. If a voltage is placed across a cathodic or semiconductive material, the repulsive force by the negative voltage at the left end causes the free electrons to move toward the right. The attractive force produced by the positive voltage at the right end pulls the free electrons to the right. The result is a net movement of free electrons from the negative end of the material to the positive end. The movement of the free electrons from the negative end of a material to the positive end is the electrical current. Current in a conductive material is measured by the number of electrons that flow past a point in a unit of time. I is equal to Q over T. 1 ampere is the number of electrons having a total charge of 1 C moving through a given cross-section in 1 second. The ideal current source can provide a constant current in any load. When there is current through a material, the free electrons occasionally collide with atoms. These collisions cause the electron to lose some of their energy, and thus their movement is restricted. And heat is produced by the collisions of free electrons and atoms. The property of a material that restricts the flow of electrons is called resistance. 1 ohm of resistance exists when there is 1 ampere of current in a material with 1 volt applied across the material.
Okay, good. And we move to the next one. 许荣安同学在吗？
嗨，
在这哈。OK， 好，那准备好。
有听到。
OK, start.
The reciprocal of resistance is conductance. It is the measure of the ease with which current is established. The formula is 这个要念。Find the resistance values in ohms and the percent tolerance for each of the color-coded resistors. Red, violet, Find the resistance values in ohms and the percent tolerance for each of the color-coded resistors. The resistance of a wire depends on 3 physical characteristics. A. Type of material. B. Length of wire. And C. Cross-sectional area. The formula for the resistance of a wire of length L and cross-sectional area A is find the resistance of 100 feet length of copper wire with a cross-sectional area of 810.1 centimeters. The resistivity of copper is 10.37 centimeters at 20 degrees. Note: circular mill is the cross-sectional area of the wire with a diameter of 0.001 inch or 1 mil. The instrument used to measure voltage is a voltmeter. The instrument used to measure current is an ammeter. And the instrument used to measure resistance is ohmmeter. All 3 instruments are combined into a single instrument known as a multimeter. To measure current with an ammeter, connect an ammeter in the current path with a series connection. To measure voltage with a voltmeter, connect a voltmeter across the component for which the voltage is to be found with a parallel connection. To measure resistance with an ohmmeter, the resistor must first be removed or disconnected from the circuit. Ohm's law states that the current is directly proportional to the voltage and inversely proportional to resistance. For a constant value of resistance, calculate the current for several values of voltage ranging from 10 volts to 100 volts in the following circuit. Note, the graph of the I values versus the E values is a straight line. How much voltage will be measured across the resistor in the following figure? Substitute the values for I and R into the formula V equals IR. E equals L. When a constant force is applied to move an object over a distance, the work is Newton times meter. The unit for work is joule. Energy is closely related to work. Energy is the ability to do work. It is measured in the same units as work, namely joule. Note, joule equals Newton times meter and equals coulombs times voltage. For example, if we slide a box along a floor for 5 meters with 100 Newton force, the work is
Okay.
work.
Okay, you can stop. Wait a moment. 数学是，你要练可以啦，不过就是 inline 的部分练一下就好了。那个单独的那 equation 的部分，我想请同学跳过就好了，因为这个有时候我也不知道同学会不会念哈，所以我想那个就是如果是 inline 的哈，比如说你在那个 line 里面有一个什么一个数字或者是一个 equation， 你就把它念出来没有关系啊。但是如果是单独列出来的那个 equation 的话，就请同学跳过就可以哈。所以我想这个刚刚有同学发问哈。我们先做一下说明哈。Okay, so we move to the next one. 周胜哲同学，周胜哲在吗？这个同学是哪一位？064苏静渊是不是？06是苏静渊同学嘛？对，你在吗？麦克风开一下吧。
喂，有听到吗？
是苏静渊没错嘛？对。
对，不好意思。
好，那这样子，等一下哈。苏静渊是好，那我们先跳回去给苏静渊念一下哈。等一下哈。OK， start.
Energy is the ability to do work, and power is the rate at which energy is used. In other words, power is a certain amount of energy used in a certain length of time, expressed as follows. For example, in previous example, if the box is moved in 10 seconds, the power is 200 watts. When there is current through a resistance, the collisions of the electrons as they move through the resistance give off heat, resulting in a conversion of electrical energy to thermal energy. The amount of power dissipated in an electrical circuit can be expressed as follows. Watt's law. Calculate the power in each of the 3 circuits shown in the following figure. When there is current through a resistance, electrical energy is converted to a heat energy. Therefore, the electrons have more energy when they enter a resistor than when they exit the resistor. Recall that voltage equals energy per charge, and the same number of electrons that enter R1 also exit R1. So Q is constant. However, the energy is less than W enter, so the voltage at the right end of R1 is less than the voltage at the left end. This decrease in voltage across the resistor due to a loss of energy is called a voltage drop. A series circuit provides only one path for current between 2 points, so that the current is the same through each series resistor. 5 resistors are positioned on a portal board, as shown in the follow figure. They are in series connection. For any number of individual resistors connected in series, the total resistance is the sum of each of the individual values. Find the current in the following circuit. The total resistance is EDO. Next, use Ohm's law to calculate the current. Remember, the same current exists at all points in the circuit. Thus, each resistance has 20 mA through it.
Okay, 苏金同学 you can stop. So next one, 周胜哲同学在不在？周胜哲同学在不在？我确定不在哈。那林冠成同学，林冠成同学，哎，
喂，在。
好，听得到哈。好，那准备开始哈。Okay, stop.
The sum of all the voltage drop around a single closed path in a circuit is equal to the total source voltage in that closed path. Kirchhoff's voltage law. Kirchhoff's voltage law can be expressed by the equation Vs equals a circuit consisting of a series string of resistors connected to a voltage source acts as a voltage divider. For example, in the following figure, since each resistor has the same current series, the voltage drops are proportional to resistance volumes. The smallest resistor has the least voltage, and the largest resistance has the most voltage. Determine the voltage between the B to the D. The total resistance RT is 12.5 kΩ. The voltage from B to D is the combined voltage drop across both R2 and R3 in the case 23 voltage. The power dissipated by each individual resistor in a series circuit contributes to the total power in the circuit. The total amount of power in a series resistive circuit is equal to the sum of the power in each resistor in series. Determine the total amount of power in a series circuit. The total resistance is 100 ohm. The total power dissipation is 2.25 watt. We can also determine the power of each resistor separately and add all these powers. First, the current is 150 mA. Next, calculate the power for each resistor using. Now, add this power to get the total power. The sum of the individual power is equal to the total power as determined by the formula. An open in a series circuit prevents current. A short in a series circuit, a portion of the series resistance is bypassed, causes more current. When two or more resistors are individually connected between the same 2 points, they are in parallel with each other. Each parallel path in the circuit is called a branch. 5 resistors are positioned on a board, as shown in the following figure. They are in parallel connection.
Okay, you can stop. And then we move to the next one. 庄凯浩同学在吗？
在。
OK， 好，那准备好。
对。
OK，start.
For any number of individual resistors connected in parallel, the total conductance is the sum of each of the individual values. Calculated the total parallel resistance between points A and B of the circuit shown in the following figure. First, find the conductance, which is the reciprocal of the resistance of each of the three resistors.
Reciprocal.
Reciprocal. The conductance has the units of Siemens. Next, calculates RT by adding G1, G2, and G3 and taking the reciprocal of the sum. The sum of the currents into a node total currents in is equal to the sum of the currents out of that node total currents out. Kirchhoff currents law.
Kirchhoff.
Kirchhoff. A node is any point in a circuit where two or more components are connected. Kirchhoff's currents law KCF can be expressed by the equation. A parallel circuit acts as a current divider because of the currents entering the junction of parallel branches divides up into several individual branch currents. For example, in the following figure, since the same voltage drop is across each of the resistors in parallel, the branch currents are inversely proportional to the values of the resistors. The smaller resistance have the most currents and the large resistance has the least currents. Determine the current through each resistor in the circuit of the following figure. First, calculate the total parallel resistance. The total current IT is 10 mA and the voltage Vs across each of parallel resistors is the same. Vs equal to IT multiplied by RT and Vs equal to Ix multiplied by Rx for each branch current Ix. As a result, Ix equal to RT divided by Rx multiplied by IT, and each branch current can be calculated by.
Okay, you can stop now. The equation we also say that Ix equal to the RT over Rx times IT. OK，
OK，
就大概是这样讲了哈。那个我们就移到下一位同学哈。那个吴成进同学在吗？
教授你好。
OK， 好，那准备好。
听到吗？
有，准备开始好。
好，谢谢。
OK, you can start now.
The total power in a parallel circuit is found by adding up the powers of all the individual resistors, the same as for series circuits. Determine the total amount of power in a parallel circuit. The total current is 200 mA. The total resistance is thus the total power. We can also determine the power of each resistor separately and add all these powers. First, the voltage across each branch of the circuit is. Next, calculate the power of each resistor using P equals Vs power 2 over R.
Vs squared over R.
Oh, Vs squared over R. Now add these powers to get the total power. Note the small difference between 444 MW and 446 MW is rounding error.
Milliwatt.
minimal. When an open occurs in a parallel branch, the total resistance increase, the total current decrease, and the same current continues through each of the remaining parallel paths. For example, in A, I1 equals 50 voltage over 560 ohms equals 89.3 milliamp A, and I2 equals 50 voltage over 100 ohms equals 500 milliamp A. Thus, the total current IT equals I1 plus I2 equals 589.3 milliamp A. If R2 is open, the total current is 89.3 milliamp A, as indicated in B. I1 is unchanged. Similarly, if R1 is open, the total current is 500 milliamp A and indicated in C.
Okay, you can stop. And we often say that the 500 milliamp. Okay. And then we move to the next one.柯晨宇。
喂。
哎。
喂。
OK， 好，准备了，等我一下哈。Okay, you can stop now.
Okay. R6 is connected in parallel with the series combination of R1 and R4. The series parallel combination of R1, R4, and R6 is in series with the series parallel combination of R2, R3, and R5. First, determine the current through R4 if Vs is 5 voltage. There are two main branches in the circuit. The leftmost branch consists of only R1. The equivalent resistance of the rightmost branch is R2 plus 3. I2 is the total current through the main branch. If we find I2, we can use the current divider formula to find I4 through R4. Therefore, I4 is 3.45 milliamp. A voltmeter must be connected in parallel with a resistor in order to measure the voltage across the resistor. However, the voltmeter has an interval resistance appears in parallel with R3. If Rm is much larger than R3, the loading effect can be neglected. But if Rm is not sufficiently greater than R3, the voltage across R3 is altered by the loading effect of the voltmeter. A two-port network has 4 port variables, V1, I1, V2, and I2. If the two-port network is linear, we can use two of the variable excitation variables and the other two as response variables. For example, the network operation can be described by the two equations. The 4 parameters y11, y12, y21, and y22 are admittance measured in siemens, and their value completely characterize the linear two-port network. The short-circuit admittance, or Y parameter, Relaxation is based on exciting the network by V1 and V2. Then the 4 Y parameters can be optioned as first. Y11 is the input admittance at port 1 with port 2 short circuit. Y12 represents transmission from port 2 to port 1, and it represents internal feedback in the network. In addition, Y21 represents transmission from port 1 to port 2 and provides a measure of forward gain. Y22 is the admittance looking into port 2, while port 1 is short circuit.
Okay, you can stop. Exciting and excitation. Okay.
Okay.
好，next one，林志堂同学 ，Are you here？ 林志堂同学在线上吗？确定不在哦，林志堂。OK，next one， 张景祥。
喂，教授好。
好，那准备开始哦。
好。
OK，start。
The open circuit impedance or the parameter characterization is based on exciting the network by I1 and I2. Then the network operation can be described by the two equations.
Impedance， 还有这个 calculation.
Therefore, the parameters can be obtained as the hybrid or edge parameters. Characterization is based on exciting the network by I1 and V2. Then the network operation can be described by the two equations. The four edge parameters can be obtained as
calculation. Calculation. Okay. Sometimes I will use就试看看吧哈。对，忘了跟大家讲那个这个网站，如果一天查太多次的话，还会叫你注册。不过我们今天只有查一次，应该还好。
Is exhilarating. It's energizing. It is seen as a positive experience, and it makes you approach. It makes you more likely to help. And since then, there's been other. Is exhilarating. It's energizing. It is seen as a.
而且那个网站好像有点慢哈，等一下哈。
Of it is the characterization of the of it is the characterization of it is the characterization of the
scratch. Now, obviously, this is not subtle characterization, but scratch. Now, obviously, this is not subtle characterization, but
这样会念的吗
？Characterization.
Okay, continue.
The inverse hybrid or G-parameter characterization is based on exciting the network by V1 and I2. Then the network operation can be described by the two equations. The four G parameters can be obtained as the usable circuit symbols are shown in the following figure. A two-port network can be represented by an equivalent circuit based on the set of parameters used for characterization.
还有这个 represented， 反正你自己回去自己回去听一下了，哦，就这样哈。
好，
好，继续。
好，谢谢。 The two-port network can be represented by an equivalent circuit based on the set of parameters used for categorization. Then theorem provide a method for simplifying a circuit to a standard equivalent form. You will not be able to determine which box contains the original circuit and which contains the Thevenin equivalent circuit. That in terms of what you can observe by electrical measurement. Both circuits appear to be the same.
Thevenin theorem， 这个是人名哈，这个是对，这个是人名哈 ，equivalent 哦，还有这个 electric measurement 哈，还有这个 equivalent 哈，这反正就这几个字其实都念得不太好了哈，那就是你的诊断哈，整段那个丢上去给他念，我就整段给他丢上去给他念哦，啊多听几次就会改善了这样，好不好？那因为我们的课不是英文课啦，啊，但是就是至少到那个简单的那个英文对答啊，那个听起来不会觉得怪怪就好，这样好不好？我们没有要求到每个字都要咬得很准哈，就是那个像很多同学大概都有1-2个字有一点问题啊，那我也没有特别要讲什么，但是你的字多了一点了，哦，就这样。OK， 好，那我们就下一位哈。来，那个这是易嘛？彭义璇同学。
对。
哦，这是易的，好，那准备好。
对。
好，开始。
Thevenin's theorem is used to represent a part of the network by a voltage source VT and a series impedance VT. VT is determined by simply open circuiting the two terminals of network A and measures the voltage that appears between these two terminals. To determine VT, we reduce all independent sources in network A to 0 by short circuiting voltage source and open circuiting current source. The impedance VT will be equal to the impedance of network A after this reduction has been performed. Example, find the Thevenin equivalent circuit between the open output terminal A and B of the circuit. Since there is no current from RC, R4 VT equals VAB. Thus, example, to find VT, we reduce all impedance sources
independent
source to 0 by short circuiting voltage source and open circuiting current source. Then RE appears in parallel with R2 plus R7, and RC is in series with the series parallel combination of R1, R2, and R7. Example, you can reduce the circuit to the repeated application of Thevenin's theorem.
Thevenin's theorem.
Thevenin's theorem. A redstone bridge current circuit is shown in its most common dimension configuration. The output voltage is taken between A and B. Then, when output voltage VR between terminals A and B is equal to 0, the redstone bridge is in the balance bridge condition.
Okay, you can stop. Redstone bridge. Okay.
Redstone bridge.
Okay. So we move to the next one. 陈胜明同学在吗？ 陈胜明同学在不在？确定不在哦。好，那下一位张佑伟同学。
喂。
OK，
这样听得到吗？
听得到，听得到哈。
OK.
Okay, you can start now.
Therefore, the voltage across R1 and R2 are equal. V1 equals each V2, and the voltage across R3 and R4 are equal. V3 equals V4. We can obtain, since I1 equals I3 and I2 equals I4. All the current terms cancel, leaving the resistor ratios. Simplifying a Weston bridge with Thevenin theorem.
We skip this slide. Okay, continue.
In analyzing a network, we find a voltage control current source Ix appearing between two nodes whose voltage difference is the controlling voltage Vx. That is, Ix equals Gm times Vx, where Gm is a conductance. We can replace this voltage control current source by an impedance Zx equals Vx over Is equals 1 divided by Gm. Because the current drawn by this impedance will be equal to the current of the voltage control current source that we have replaced. For a given voltage source, minimal power is transferred from a source to a load when the load resistance is equal to the voltage source internal resistance. Thus, when RL equals RS, the maximum power is transferred from a voltage source to RL for a given value of Vs. The total current I is Vs over Rs plus RL. Thus, the power of resistor RL is the maximum power value of PL can be obtained by setting, therefore. Determine the load power or the variable load resistance. Notice that the load power is greatest when RL equals RS equals 75 ohms. The superposition theorem is a way to determine current in a circuit with a multiple source by leaving one source at a time and replacing the other source by their internal resistance by short-circuiting voltage source and open-circuiting current sources. Then determine the particular current with only one source in the circuit. Take the next source in the circuit and repeat the same process for each source. Finally, the actual current is the summation of particular currents.
Okay, determine. And we can start now. We move to the next one. 雷子这个怎么念呢？杰吗？
杰
吗？
有吗？
有听得到哈。
Hello.
Okay, start.
Find I2 due to ES1 I2. The actual current I2 is I2 plus I2S1 plus I2S2. Find the total current through the voltage across R3. Step 1. Find the current through R3 due to the source VS1 by shorting voltage source VS2, looking from VS1. Now apply the current divider formula to get the current through the R3 due to source VS1. Step 2. Find the current through R3 due to source VS2 by shorting voltage source VS1, looking from VS2. Now apply the current divider formula to get the current through R3 due to source VS2. Step 3. Because the currents are in opposition direction, R3 total equals.
Sorry, wait a moment. Okay. It's the end of lecture 2. Sorry.
Yeah.
We move to lecture 3. Continue.
The pulse can be described as a very rapid transition from one voltage or current level, baseline, to another level, and then after an interval of time, a very rapid transition back to the original baseline level. The rate at which the pulse repeats is a pulse repetition frequency F. The time from one pulse to the corresponding on the next pulse is a period. The relationship between the frequency and the period is F equals 1/T. An important characteristic of the periodic waveforms is the duty cycle, which is defined as the average value of a pulse waveform is as follows.
Okay, you can stop. And the next one, 赖承恩同学。
有在。
好。Okay, stop.
Determine the duty cycle and the average voltage of this waveform. The baseline voltage is at 0 volts. The amplitude is 2 volts, and the duty cycle is 1 microsecond over 10
Millisecond.
Millisecond. 1 millisecond over 10 milliseconds equals to 0.1 equals to 10%. Thus, the average voltage is a triangular waveform is composed of positive going and negative going ramps having equal slopes. The period of this waveform can be measured from one peak to the next corresponding peak, as illustrated. This particular triangular waveform is alternating and has an average value of 0. In the following simple circuit, where the switch closes and opens with a 10-second period, the instantaneous power can be calculated by the voltage applied to the resistor and the power dissipated by the resistor are shown in the following figure. Thus, the total energy delivered to the resistor during the first 5 seconds of the period is 10 multiplied by 5 equals to 50. During the next 5 seconds of the period, the power is 0. Therefore, the average power is 50 over 10. 50 joule over 10 seconds equals to 5
watt.
Recall the voltage and current waveform. By inspection, the average voltage should be 5 volts and the average current should be 0.5 amplitude. However, the root mean squares value stand for the square root of the arithmetic mean average of the square of the function. Thus, the RMS value of VRMS and IRS should be. Thus, we can obtain. Recorder instantaneous power is V square 2 over R, where V is instantaneous voltage. Therefore, the average power is, since VRS is equal to
you can just skip this equation.
Thus, the average power can be rewritten as the importance of RMS voltage and currents are less. They can be directly used to calculate the average power. Therefore, when a resistor is connected,
sorry, you can stop now. Okay. The next one, 李红斌同学在吗？李红斌同学在吗？确定不在吗？ Okay, next one, 陈世杰同学。
喂。
哎，好，那准备好。Okay, you can start.
Therefore, when a resistor is connected across the AC voltage source, it dissipates a certain amount of heat. As shown in A, in B, it shows the same resistor is connected across a DC voltage source with VDC equal to VIS. The resistor will give off the same amount of heat. The general shape of a sine wave, which can be either an alternating current or alternating voltage, shown in the following figure. The current direction is changed with the alternation of the voltage. The combination positive and negative alternations make up one cycle of a sine wave. The time required for a given sine wave to complete one full cycle is called a period. The period of a sine wave can be measured from a zero crossing to the next corresponding zero crossing. The period can also be measured from any peak in a given cycle to the corresponding peak in the next cycle. The function defined for OT is said to be periodic, provided that there is a positive number p such that for OT the number p is then called a period of the function f. If there is a smallest positive number p such that f of t is periodic, period t, we will call p the period of f. For instance, the period of the function g of t equal to cosine nt and h of t equal to sine nt is 2 pi over n, because frequency is the number of cycles that a sine wave completes in 1 second. Frequency is measured in units of hertz. The formula for the relationship between frequency and period is: all signal generators consist basically of an oscillator, which is an electronic circuit that produces sinusoidal voltage or other types of waveforms whose amplitude and frequency can be adjusted.
Okay. We move to the next one. 王凯正同学在不在？
在。
Okay. 好。Okay, you can start now.
The peak value of a sine wave is the value of voltage or current at the positive or the negative maximum with respect to zero. The maximum or peak value of the sine wave is also called its amplitude. The peak-to-peak value of a sine wave is the voltage or current from the positive peak to the negative peak. Peak-to-peak values are represented by BPP or IPP. The root mean square RMS value stands for the square root of the arithmetic mean average of the square of the function. Thus, the RMS value VRMS of the sine wave Vp sine omega t with peak value Vp and the period t equals 2 pi over omega is the average power dissipated by the resistor network with a sine wave voltage source can be calculated by. Therefore, when a resistor is connected across an AC voltage source, it dissipates a certain amount of heat power as shown in A. In B, it shows the same resistor is connected across a DC voltage source with VDC equals Vrms. The resistor will give off the same amount of heat power. The average value of a sine wave when taken over one complete cycle is always 0. Thus, the average value of a sine wave is defined over a half cycle rather than over a full cycle. Thus, the half cycle average value of the sine wave Vp sine omega t with peak value Vp and period t equals 2 pi over omega is. The angular measurement of a sine wave is based on 360 degrees or 2 pi rad for a complete cycle. A radian rad is equal to 57.3 degrees. In a 360 degrees revolution, there are 2 pi radians. In A, sine wave P is shifted to the right by 90 degrees with respect to sine wave A. In this case, sine wave B is said to lag sine wave A by 90 degrees. In B, sine wave B is said to load sine wave A by 90 degrees.
Okay, you can stop. Next one， 蔡安林同学在吗？请问一下，蔡安林同学在吗？你声音可以再大声一点吗？声音我听不清楚。有办法调整一下麦克风输入吗？吼。
这样听得到吗？
好，可以，好。Okay, you can start.
The instantaneous value of a voltage sine wave at theta can be expressed as this formula also applies to a current wave. When a sine wave is shifted to the right of the reference by a certain angle, phi, the general expression is when a sine wave is shifted to the left of the reference by a certain angle, phi, the general expression is. If a sinusoidal voltage is applied across a resistor, there is a sinusoidal current, Kirchhoff's voltage and current laws apply to AC circuits as well as to DC circuit.
Sinusoidal. Okay.
Determine the RMS voltage across each resistor and the RMS current in the following figure. The source voltage is given as a RMS value. Also, determine the average value of the total power. The total resistance of the circuit is. Use Ohm's law to find the RMS current. The RMS voltage drop across each resistor is. Thus, the average value of the power is. In many practical circuits, you will find both DC and AC voltage combined. These two voltages will add algebraically to produce a AC voltage riding on a DC level. If VDC is greater than the peak value of the sinusoidal voltage, the combined AC and DC voltage is a sine wave that never reverses polarity and is therefore non-alternating.
Polarity.
The oscilloscope is a
oscilloscope.
Oscilloscope is a graph displaying device that traces a graph of a major electrical signal on its screen. The vertical axis of the display screen represents voltage and the horizontal axis represents time.
Okay. So the next one, 吴凯翔，在吗？
请问听得到吗？
好，听得到。
好。
You can start.
等我一下，我翻一下那页。好，那我开始。The voltage probe is used for connecting a signal to the oscilloscope.
Okay. Wait a moment. I move to the lecture 4. Okay, continue.
A capacitor is an electrode device constructed of two parallel conductive plates separated by an insulating material called a dielectric. A capacitor stores electrical charge and has the property of capacitance. In the neutral state, both plates of a capacitor have an equal number of free electrons. When the capacitor is connected to a DC voltage source through a resistor, electrons are removed from plate A and are deposited on plate B. As plate A loses electrons and plate B gains electrons, plate A becomes positive with respect to plate B. During this changing process, electrons flow only through the connecting lens in the source. No electrons flow through the dielectric of the capacitor because it's an insulator. The movement of electrons ceases when the voltage across the capacitor equals the source voltage. If the capacitor is disconnected from the source, it retains the stored charge for a long period of time and still have the voltage across it. A charged capacitor can act as a temporary battery. The amount of charge that a capacitor can store per unit of voltage across its plates is its capacitance, C. The capacitance is a measure of the capacitor's ability to store charge and can be expressed by the following formula. C in farad equals to Q in coulombs over V in volts. 1 farad is the amount of capacitance when 1 coulomb of charge is stored with 1 volt across the plates. For example, a 2.2 microfarad capacitor has 100 volts across its plates. The charge stored in the capacitor is Q equals to C times V equals to 2.2 microfarad times 100 volts equals to 220 microcoulomb. The current and voltage of a capacitor have the following relationship. I of t equals to dq of t dt equals to dc times of v of t dt equals to c times dv of t dt. The instantaneous power delivered to the capacitor is P of t equals to I of t times v of t equals to c times v of t times dv of t dt. Thus, if the capacitor is connected to a DC voltage source V, the total energy stored in the capacitor is W equals to the integral from 0 to t over V of t dt equals to the integral from 0 to t over c times v times dv dt dt equals to the integral from 0 to v over c times v dv equals to a half times c times v squared evaluated from v equals to 0 to v equals to a half times c times v squared.
You can sum up.
好，谢谢教授。
好。下一位哈，等下看，我想哈， 下一个，下一个陈静同学。
在，喂，
好，
喂，
好，听得到，嘿。
OK。
Start.
Every capacitor has a limit on the amount of voltage that it can withstand across its plates. The voltage ratings specific is the maximum DC voltage that can be applied without risk of damage to the device. The temperature coefficient indicates the amount and duration of a change in capacitance value with temperature. For example, a negative temperature coefficient of 150 ppm for a 1 microfarad capacitor means that for every degree Celsius rise in temperature, the capacitance is decreases by 150 farad.
Picofarad.
Okay.
And specifies. Okay, continue.
The dielectric of any capacitor will conduct some very small amount of current. Thus, the charge on a capacitor will eventually leak off. Equivalent circuit for the capacitor is
non-ideal
capacitor is shown in the following figure. The parallel resistor R leak represent the extremely high resistance of the dielectric material through which there is leakage current. The following parameters are important in establishing the capacitance and the voltage rating of the capacitor: plane area, plane separation, and dielectric constant. The formula for calculating the capacitance is a capacitor having a plane area of 0.01 meter square and a plane separation of 1.27 times 10
to the power of -5.
10 to the power of -5. In addition, the dielectric constant is 5 times 8.85 times 10 power to the negative 12 farad over F. Then the capacitance is.
Okay, you can stop now. And we have some students. They didn't. Okay. We back to the. 陈家军同学在不在？
老师有听到吗？
有，好，你等我一下陈家军。OK， you can start now。
13页开始吗？
就从这里开始。
好。The current is the same at all points in the series circuit. Thus, the total charge moved through the circuit equals the charge stored by C1 and also equals the charge stored by C2. Therefore, Qt equals Q1 equals Q2. The voltage across each capacitor depends on its capacitance value by Kirchhoff's voltage law. Substitute V equals Q over C into formula.
In addition, since we can obtain the voltage across each capacitor as follows. The largest value capacitor in a series connection will have the smallest voltage across it. The smallest value capacitor will have the largest voltage across it.
Smallest 好像没听你念出来哈。好，来继续。
In a general circuit with n capacitors in series, the formula for total capacitance is as follows. The total series capacitance is always less than the smallest capacitance. Find the voltage across each capacitor. Calculate the total capacitance. The voltage across capacitors are as follows. The voltage across capacitors are as follows. The voltage across both capacitors is the same in a parallel circuit. A total charge moved through the circuit. Part of the total charge is stored by C1 and part by C2. Therefore, Qt equals Q1 plus Q2. Since Q equals C plus V and the voltage across both capacitors is the same, we can get the following relationship.
The Q equal to C times V.
Or C times V. In a general circuit with n capacitors in parallel, the formula for total capacitance is as follows. The total parallel capacitance is the sum of individual capacitance. A capacitor will be charged when it is connected to a DC voltage source. When the capacitor is fully charged, there is no current. When a conductor is connected across a charged capacitor, the capacitor will be discharged. A capacitor appears as open to a constant voltage, and it appears as a short to an instantaneous change in voltage.
Okay, you can stop now. So the next one,温敏轩在吗？在吗？好，在这。
大家听到吗？
有，好。Okay, you can start now.
If the switch is closed after t equals 0, the charging curve can be derived as follows. By Kirchhoff's voltage law, this circuit can be modeled by. Thus, we can obtain a linear first-order differential equation. The solution of the equation is, from the initial condition, Vc of 0 equals Q of 0 over C equals 0. We can obtain Q of 0 equals 0. And thus, C1 and can be calculated by. Therefore, the equation for the charge stored on the capacitor is. Finally, we can get the charging curve for voltage across the capacitor. The time constant determines the rate at which the capacitor charges or discharges. The time constant is defined as. The charging curve is an increasing exponential. It takes 5 times constant to reach 99% of the final voltage. This 5-time constant interval is generally accepted as the time to fully charge a capacitor, and it is called the transition time. If the capacitor is fully charged to Vs and the switch is closed after t equals 0, the discharging curve can be derived as follows. By Kirchhoff's voltage law, this circuit can be modeled by. Thus, we can obtain a homogeneous linear first-order differential equation. The solution for this separable equation is, from the initial condition, Vc of 0 equals Q of 0 over C equals Vs, we can obtain Q of 0 equals Vsc,
and thus C2 can be calculated by. Therefore, the equation for the charge stored on the capacitor is. Finally, we can get the discharging curve for voltage across the capacitor. The time constant determines the rate at which the capacitor charges or discharges. The time constant is defined as. The discharging curve is a decreasing exponential. It takes 5 times constant to reach 1% of the final voltage. This 5 time constant interval is generally accepted as the time to fully discharge a capacitor, and it is called the transition time.
Okay, you can stop now.
谢谢教授。
好，next one，这里刘介恩同学在不在？刘介恩同学在不在？要不在线上哈？确定不在哦。这个上礼拜就没上来，然后跟我说要改这礼拜，然后这礼拜没上来，如果再跟我说要再改下礼拜，我就不理他了哦。确定一下，刘介恩同学对不对？怎么了？哦，这个等一下哦，那个刘介恩同学，刘介恩同学对不对？好，确定不在哦。那个大家都证人了哈，这个同学就是说要改这个礼拜，然后又没有上来哈，我们就不管他了哈。刘健同学哈，然后还有没有？好，那个刚刚是什么97是不是？陈胜敏同学你在线上吗？哈，
在，我在。
好，
有听到吗？
有，等一下。好 ，start。
For a circuit shown in the figure, calculate the voltage across the capacitor every 0.1 ms for one complete period of the input waveform. The period of the square wave is 1 ms, which is approximately 12 tau. This means that the capacitor can fully charge and fully discharge. For the increasing exponential, phi for decreasing exponential phi c e equals ps e power minus t divided tau. In this equation, the time is shown from the point when the change occurs, subtracting 0.5 ms from the actual time. The input waveform and output waveform are shown as follows. We recall from calculus the Lewis formulas are. Thus, we define the exponential function e power g for g equals r plus jxt and arbitrary complex number to be. For example, in addition, the polar form of a complex number a plus ej can be obtained from. Thus, Lewis formula indicates that sine waves can be represented mathematically as. In AC circuits, analyze the frequency factors is often common to all component. Therefore, we can factor out it and leave just the M2 and phase. Thus, the phasors or the phasors transform for the above sine wave can be expressed as a result. The phasor can be inverse transformed to the original function by
here AC circuit analysis. Okay.
Analysis.
Okay. You can stop.
谢谢教授。
好。所以有没有在线上的同学，然后没有讲到的？请问有没有在线上的同学，然后刚刚没有讲到的？有没有？有没有同学在线上还没有讲到的同学？没有。好，那我想那个剩下的时间的话，就是说那个一个是再跟大家说一下哈，就是说我不知道期中考哈，有些同学考得不太好了哦，所以我们再跟大家强调一下，就是说那个接下来的期末考的部分是会含前面的 Lecture 1到 Lecture 6的部分哈，至少一半的分数哈，所以那个前面的部分大家已经看过一次了哈，所以好好把握好这一半的一个分数这样子哈，然后那个后面的那个的部分当然一定也会考了哈，所以这个部分的范围哈，就是说虽然看起来很大，但事实上是大家会比较好准备哦，因为如果都考后面的话，后面其实比较难。哦，所以就是说涵盖前面的一个内容的一个部分哈，所以请大家期末考的部分必须要好好的去做一下准备这样哈。那另外的话就是说不知道同学对这个 EMI 的这个部分哈，我们的一些教学的那些录影档哈，还有就是上课的方式，还有包括就是这一次的这个活动，不知道同学有没有什么建议？也可以用打字分享或者开一下麦克风都可以说一下哈，有没有同学有什么样的一个建议或者是一些意见要反映的哈？其实我也很想了解一下，说大家有事先准备一下这次的活动吗？还是就现场直接上？你也可以打字一下，表达一下你是怎么做的哈，是吧？就大家是直接都不用准备哈，直接就现场就上了，还是怎么样？还是有特别把每个讲义都自己念过一遍的？有没有？大家是怎么做的呢？有些人是会准备一部分，其他人呢？其他人会就是会去自己念看看吗？念给同学听，有没有人会这样做的哈？就是同学互相讲给对方听。OK， 我看一下念到哪里哈。对的，就是没有错哈，就是说因为有些字你没有真的认真去念过的话那个知道是什么意思啦，但真的叫你念的时候那个不知道怎么念这个就是我们的目的就是说我们整个数学符号发音对照表。对，没有，这个是需要的这的确是需要的，因为我自己上课也是要准备一张所以我想这一张那个忘了不知道有没有秀给大家看之前也是，就是这个也是要念过这些东西那个上课前也是要念一下看看我们讲这些小数、分数加法、减法、乘法、除法、exponential 次方时间、日期那公式这点这个一定都要准备的啦一定要准备才能够把这个东西讲好这样子同学，因为我们只有叫你念文字的部分啦那个了不起就一点数字而已，所以应该还好啦但是我们现在是这样，就是说因为大家以后如果说你继续念研究所或者是就算你没有念研究所，你出去外面工作我们这一行就是说会很有比较多的机会会碰到外国人所以这个多少大家都会有一些我们讲英文沟通的一个机会啦那我们整个专业的部分在数学电子学部分里面，其实那个生字并没有很多我想说这些专业的智慧的部分我们没有特别整理给大家了但是大家在看我们的讲义的过程中，应该会看到一些字不认得的，就应该去查一下字典，然后把它那个音标标出来嘛然后刚刚也有介绍过2个网站嘛练习去练一下自己练习去讲一下这样子或者是把那个句子丢到那个我们刚刚讲的那个 English 或者是那个text to speech 的那边，让他去讲看看听看看这样子自己练习一下这样子那我想这个会对大家以后在做这个 English 的这个 oral 的 representation 的部分一定会有很大的一个帮助这样子那另外就是跟大家说一下就是我们下学期会有3门 EMI 的课程就是说大家大2下的必修课 好，大二下的必修课的部分哈，我们已经把那个计算方法概论、系统程式的部分应该对，还有另外一门那个物件导向程式设计我们3门课我们都有一班放成 EMI 教学那个就请同学这一期有修这一门课 EMI 的同学下一期也欢迎继续修啦那有些老师的话都可能会比较倾向像我一样，就是说录一下那个英文的录音档，这样大家可以按暂停这样那这样比较不会影响到大家那个听力也没有问题啦就是说你就暂停一下，然后再听一次嘛这样子那所以大家不要太担心那个放胆的把它选下去这样那这个下一期的部分我们一样有一些 EMI 的课程给大家修那因为国家双语化的一个计划，它大概会推行10年嘛所以我想我们系上虽然没有特别去分一个叫做全英文班但是我们就是会有一半的学生，大概我们希望说他可以就主动去修习这个 EMI 的课程但是如果说你真的那个英文听力真的实在是太不行的同学，那反正还有一班中文的嘛那个就还是有得选啦但是我想大家修过这一期的课应该知道其实也还好啦就是还好啦，一般老师大概都中英文的资料都会提供给你啦那就是说因为我们主要还是专业课程的讲授但是就是要让大家就是说这些整个在 English 这些slide你要整个这样当做一个报告来讲也都没有问题那这样子就 OK 了这样子所以我想这个部分的话再跟大家就是说明一下那欢迎大家继续选修其他的 EMI 的课程，还有这个后续的这个选修课的部分江正国老师也开了很多大学部的 EMI 的选修课程这样子那么公院的部分有这个修多少学分就奖励多少钱大家就甭谈了就是说那个赚点钱了，反正又不用什么伤脑筋了，就是修个课就可以赚了所以那个部分也鼓励大家就是说有 EMI 课你就去修了那个累积到好像不知道是20几学分就可以赚8000那个不用任何条件就是你只要有修就可以没有过也没关系就是反正你只要有修就好了你只要有修选课记录出来了你有修那个 EMI 的班这样就可以了就可以所以鼓励大家就是去修一下这样好那最后看看大家还没有什么样的一个意见，有没有什么样的意见和建议要讨论或表达的那之后我想很快就会有那个学校的那个问卷了如果对我们的课程一些改善有什么样的一个建议，之后也欢迎在填写学校的问卷的时候填写文字的意见然后再提供给我们做后续开课的那个修正这样子好不好那个我想那个这一期大家 get 趟不知道觉得好不好玩这个大家走 get 趟的作业不知道觉得怎么样那个上礼拜的同学是说有点小麻烦但是希望下一届的人也可以一样做因为他们觉得很麻烦，所以下一届的人一定也要走过一样的路这样子这个大家这些同学不知道觉得怎么样，大家在走 get 趟的一个作业的部分喜欢这种形式吗有没有什么意见给我的有吗？大家觉得怎么样？下一届是不是继续就这样子教？有没有同学有意见的？好是好，还有没有什么建议？有没有大家还没有什么建议？想一下好，那剩下反正就是想到什么，其实我们欢迎在社团上面可以就是贴文讨论但是这一期的同学那个问问题都喜欢私下问就是不太喜欢公开在社团贴文其实我们是说你哪一页不懂，其实是说截图一下在社团问，然后我们就看到就回答但很多同学喜欢贴匿名的，要不然就是喜欢就是私下问这样的，其实不用了我觉得我们其他的研究所的课在社团大家都是狂贴就是问题都丢上来狂贴来问这样子那这样比较能够快解答你的问题这样子那也可能是大家都听一听觉得没有什么太大的问题这有可能不过这通常那个考试看起来成绩不是这样子的就是让大家其实好像不少题目其实还不太会算嘛所以期末考再提醒大家一次我们讲义上面的题目你是不是遮起来会不会算如果你遮起来不会算，你期末考一样是很惨的好不好好，那如果大家没有问题的话，我们今天就到这边还有没有什么问题最后的机会好，那如果没问题我们就到这边结束那谢谢各位参加拜拜